a probability lesson. We're going to focus on compound events and the difference between independent and dependent events. Just remember, compound events are two or more events considered at the same time, and your probability has to be calculated on whether the event is independent or if the event is dependent. Okay. So an independent event. The outcome of the first event does not influence the outcome of the second event in any way. The total possible outcomes, the denominators in your probabilities, will stay the same. A dependent event is the outcome of the first event will change the outcome of the second event. And so your denominators will also change. They will not be the same if you have a dependent event. All right, determine if these are independent or dependent. Knowing which ones they are is very important whenever you're calculating your probabilities. All right, flipping a coin and then rolling a number cube. So if I flip the quarter, it lands, and then I roll the dice. Does that quarter have anything to do with what that dice is going to be? No. So in this case, these would be independent events. Given marbles, a bag of marbles, selecting a red, not putting it back, and then selecting a blue. What happened to the number of marbles in the bag when you took the red out? It went down, and so this one would be a dependent event. All right, choosing a Dum Dum from the container, putting it back because that wasn't the flavor you wanted, and choosing another. When you put it back in there, did the number of Dum Dums in the container change for your second trial? No. So this would be an independent event. All right, so calculating the probability of independent and dependent events is the same process. Your probabilities may be different for dependent events, but the steps are the same. So you treat each event individually. Look at it as if it's the only thing happening. Don't worry about the first event after you've completed it when you calculate the second event. And then when you're dealing with probabilities, you're always looking at what are you looking for and the total possible outcomes. Whether it's based theoretically or experimentally, it's still the same setup. Okay. Determine the probability of the first event. Just figure out its probability. Then determine the probability of the second event. Make sure if your total possible outcomes changed or not. If they did, if the item was replaced, it doesn't change anything. If the item was removed, then your outcome changes. It goes down. And then you just multiply the two probabilities. So let's just say I have these numbers. I have the probability of 1/3 of something happening and the probability of 2/7 of something happening. How do I deal with those fractions? Well, you just multiply the numerators, multiply the denominators. So 1 times 2 is 2, and 3 times 7 is 21. And so my chance of this event happening is only going to happen 2 out of 21 times that that the experiment was performed. Okay, so let's look at a few things. Some examples. What is the probability of rolling a 6 on a 6-sided number cube and spinning a blue on the spinner? I like number cubes and spinners. All right, so I'm going to deal with my first step. Remember, the first step is figuring out the probability of your first action. My first action is rolling a 6. So here's my cube. There's my items. I only want the 6. So there's only 1 out of 6 chance that I'm going to get a 6 when I roll that number cube. All right. My second event, or my second step, is to calculate how many times I can get a blue on that spinner. And so there is one section of blue, and there's 4 colors. So there's only 1/4 of a chance that I can get a blue on our spinner up here. Then the third step is multiply the two probabilities. Just multiply the numerators, multiply the denominators. So 1 times 1 is 1, and 6 times 4 is 24. And so 1 time out of 24 times would that theoretically happen, or would happen. And so that's all you have to do to find compound probabilities. All right, let's look at another example. Smokey has 7 toys in his basket. Smokey is my cat, and he has toys all over the house, and Nerf bullets are his favorite. So I didn't put that in there though, I should have. All right, so let's see what's in his basket. He has a stuffed dog, a baseball, a little bitty football, a bird, a little car, a mouse, and a bottle cap. Yes, he likes trash to play with. Okay, so what's our question? What is the probability Smokey will choose the yellow car first, lose it under the couch, and then choose the bottle cap? Okay, the thing about losing it under the couch, if you've ever had a cat, everything gets lost under the couch. And our couches are just low enough that he can't get under there and get them. So we find his toys under the couch all the time. Okay, so our first step is dealing with just the yellow car. All right, so our probability of getting the yellow car. Well, there's only one yellow car and there's 7 items. So our probability of getting the yellow car is 1 out of 7. Now our second step is losing it under the couch. Okay, well, that means he's not replacing it. So that's actually not part of the probability problem. So our choosing the bottle cap. So his yellow car is no longer in the basket. It's gone. It's been X'd out. So now, how many items are in the basket? Well, there's only 6, and there's only 1 bottle cap. So 1 bottle cap out of the 6 that are left. And then our third step is just multiplying our fractions. So 1/7 times 1/6 equals 1 out of 42. Possible. That's not a very high probability for him doing that particular action. All right, so now let's look at one that doesn't have 1 chance. All right, Lee has a jar of coins. The jar contains 7 quarters, 8 dimes, and 5 nickels. Now, if you count all of these, it's the right amount. I worked through and I put them all on there to make sure they were the right amounts. It took me a little bit of time, but it was fun. All right, so here's my jar. All right, so what are my tasks? What is the probability of the following? Okay, so now these are just single actions, simple probabilities or simple events. And so we want to look at getting a quarter, getting a dime, and getting a nickel. All right, so how many is there? Well, you can count them all or you can just add them up. There are 20. 7 plus 8 is 15 plus 5 makes 20. So quarters would be 7 out of 20. 7 quarters out of the 20. The dimes would be 8 out of 20. And you can reduce that to make it easier to work with, which would be 2 out of 5, as long as it's not the second event and the denominator changes. And you'll see what I mean by that in a second. And then the probability of getting a nickel is 5 out of 20, which is 1/4. All right, so now let's look at what is our next task. What is the probability of the following? Selecting a nickel, keeping it, that means putting it in your pocket, and then selecting a dime. Okay, so remember, our steps are determine your first probability of the first action. Then the second step is determine the probability of the second action, and then multiply your 2 fractions. All right, so the probability of getting a nickel, because it's the first action, I can use the reduced fraction, 1/4. Keeping it, though, means I now only had 19 items in the jar, and so I can't use the reduced on the dime, so I have 8 dimes, but only 19 coins in the jar. So then I multiply. Now, I prefer to reduce first, where you reduce the 4 and the 8, but I know that bothers some of my students right now. So I just multiplied across and then I reduced. And so it ended up with 2 out of 19. All right, now we have the same situation. Selecting a nickel, replacing it back in the jar, and then selecting the dime. And so how is that going to change our probability? Well, we have our 1/4 of our nickel. Then our dime, we can use the reduce because we kept the 20 at the bottom, so 2/5. And then multiply the numerators, multiply the denominator, and you end up with 2/20, which is the same as 1/10. And so 2, it'll happen 2 times out of 19. If you repeated the experiment a bunch of times, you're going to end up with that probability. Or 1 out of every 10 times. Okay. Some things to remember. Didn't need that section. As always, thanks for watching. Remember, you can email me at bethemath@gmail.com.